Thank you so much. Like Al said, I'm Kim Nye, the founder of TESS Research Foundation. Next slide, please. I'm speaking today about my family's personal journey with modeling genetic epilepsy in hopes that it highlights some of the challenges families and patient advocacy groups are facing. When my daughter Tessa was born in 2003, she began having seizures shortly after birth for no apparent reason. We saw her diagnosis shift from benign idiopathic neonatal seizures to catastrophic epilepsy. Medications, surgeries, diets, clinical trials, and research all failed Tessa for more than a decade. She was having hundreds of seizures a day, but we still had no idea why. At one point, we thought we finally had a de novo genetic diagnosis, only to find out that Tessa's sample had been switched with another child. We were 9 years into a diagnostic roller coaster, but back at square one. On August 26, 2013, our world came crashing down when I gave birth to a baby boy named Colton. He seemed healthy, but just like his big sister, Colton began having seizures shortly after birth. He was only hours old, but I knew my son would never talk or dress himself. Colton's birth made the medical puzzle a bit easier. A genetics researcher named Matthew Bainbridge was able to find a genetic marker for the disease, SLC13A5, a Citrate Transporter Disorder. But was diagnosis the finish line or the beginning of a race toward a cure? Our resourceful neurologist, Dr. Brenda Porter, agreed that diagnosis should not be the end of the journey and that we should use this genetic knowledge and translate it into reasonable metabolism-based trials of citric acid cycle intermediaries like trihexynoin and citrate. When these attempts didn't work, we decided to organize our disease community and fund research. In 2015, we started TESS Research Foundation. Next slide. Because SLC13A5 epilepsy was a newly discovered disorder, this is what the landscape looked like when we started. It was a bunch of zeros and nos. There were fewer than 10 kids diagnosed and no funding or toolkit in place to accelerate the development of treatments. I knew the future was bleak for my newborn son. I did not see any hope in the research landscape. Where was the infrastructure that could find the answers we needed in the timeline that we needed them? Next slide. The first thing we did was fund research to create animal and cellular models of SLC13A5 human epilepsy. We had been plunking dozens of drugs into our kids to see what worked. The goal now was to make the guinea pigs be the guinea pigs. And while we didn't actually make guinea pigs, we did make SLC13A5 flies, fish, mice, patient-derived cells, and organoids. Right now, our organization is interested in mechanism, drug screening and repurposing, metabolism-based therapies, and gene therapies. Unfortunately, we don't have a perfect model system for SLC13A5 epilepsy, so we developed multiple models. Different models have the potential to help us accelerate different therapeutic discoveries. For instance, it's going to be difficult to use a zebrafish in a gene therapy project, but fish can be very useful for drug screening. Next slide.
2-minute warning.
But what happens when animal models don't behave like humans? SLC13A5 epilepsy is a monogenic, loss-of-function recessive disease. The knockout mouse should be a great model for us. But whereas the kids begin seizing shortly after birth and continue to have multiple seizure types that are refractory to medication, the knockout mouse only has sporadic seizures. The significant movement and developmental delay that limit our children's opportunities in life do not seem to afflict the knockout mouse at all. Next slide. From the patient advocacy perspective, modeling the human epilepsies raises more questions than answers. How much time and funding should be put into the creation of human epilepsy models? Should we keep making mice on different backgrounds or with different mutations? Do we make bigger but significantly more expensive animal models like a ferret or a pig? Would models of rare genetic epilepsies get made without parents funding their creation? Our organization largely started out of fear that if we didn't build the SLC13A5 preclinical toolkit, then it would never get built. And what do we do when we have a potentially curative treatment, but a mediocre mouse? In our case, will we be able to get our SLC13A5 gene replacement therapy into clinical trials if the current mouse model is as good as it gets? Do my children's lives depend on a mouse? Next slide. I'm closing with a refrain that I hope is starting to sound familiar. You could go back one. Thank you. We need transformative change. We need transformative change for my Tessa and Colton, for Meredith, for Jackson, Yavi, Elena, Abhi, Sanju, Aubrey, and so many more. Thank you so much for listening to my journey.